So, welcome back everyone. My name is Akshay and welcome to this GFG POTD streak of day 88. So, today's question is of easy category that find the maximum GCD of the sibling of a binary tree. Before proceeding on to the question and the different approaches, if you are new to this channel, then please subscribe our channel and be the part of our growing family. So, let's continue. So, given the binary tree, the task is to find the maximum GCD of the siblings of this tree. You have to return the value of the node whose two immediate children has the maximum GCD. Okay, so the two children which has the maximum GCD for that pair, you have to return the value of its root node. Okay, so if there are such multiple nodes, then return the node which has the maximum value. Okay, so there is a cache also here. If there are a pair of sibling node which has the same GCD, then we have to return the root node which has the maximum value. Right. So GCD is nothing but the greatest common divisor, or also known as highest common factor, is the largest positive integer that divides both numbers without a remainder. So return 0 if the input tree is empty or that is the level of trees is -1. So the base case is for this. If root itself is null, then we have to return -1. So consider those nodes which have a sibling, return 0 if no such pair of siblings found. Okay, so as you can see here, that for this question for this tree, the answer given is as 3, and it is saying that for the above tree the maximum GCD of the sibling is formed using these two nodes 6 and 12, right? Okay, so let's take it to the paint and let's see how it is running, how the input and output is coming. So if I talk about this thing, this is the root node 4 and the sibling are 5 and 2, right? So if I talk about the GCD, that will be equals to 1 for 5 and 2. If I talk about this, the another node, that is 2, having the sibling 3 and 1, then if I say, then again the GCD is equals to 1, right? And for this 3, we have this sibling as 6 and 12, and I can see that the GCD is equals to what? It's 6, right? What's the maximum here? The GCD 6 is maximum, right? This is maximum. So from which root node? That this is 6 for the sibling 6 and 12. So what was the parent for this sibling? That was 3, right? And that's why the 3 is returning here. So I can see here ki suppose if our tree would have been like this 4 5 2 3 and 1, then you can see that for this 5 and 2 you will get GCD as 1, and for this 3 and 1 you will get GCD as 1. And according to the question, for this sibling the parent was 4, right? And for this sibling parent was is 2. Since the GCD is same, then in that case we need to return the highest parent value, that is 4, right? So let's just verify it using the compiler also. Let's just verify it. That is it. Are we on the same page? So 452 null null, and then I can say that 3 and 1, and we don't have this subtree of 6 and 12. Let's compile and run. I just want to check that are we on the same page as the question is saying. The expected output is 4. Okay. So we are on the same page, guys. So now let's dry run the second input test case. And while dry running it this time, we will deduce the pseudocode, that how are we supposed to do this question. Okay. Okay, so for this another tree, I can see that what? For this parent 1, it has the sibling of 3 and 5, and I can see the GCD of this 3 and 5 will be equals to 1. And for this 3, the 6 and 9, the GCD will be what? 3. And this 4 comma 8, the GCD will be 4. So the among the maximum is 4. So what is the parent of this sibling which is having the GCD as 4? That is 5, right? So that's why the output is given as 5. So let's now do the traversal. Since this is tree, the question is of tree. And what is tree about? Tree is all about recursion plus the traversal you do in accordance to get to your answer. So what are we doing here is, what I did, I find the first pair sibling, that is 3 and 5, which was the first root node. And then I traversed, let's say left, and then find that 3 again has some sibling, and again find the root node, again find the sibling and find the GCD, right? So I can see that I'm doing processing at root. Let me just change the color. I'm doing processing at root, right? And then I'm moving either left, you can either go left and process the this node 3, or you can process the 5. So let's move left and then right. So this is what a pre-order traversal, right? So okay, so traversal we have decided now it would be a pre-order traversal. So okay, so let's write the code. So before writing the code, we need to see that we have to maintain for each and every processing of GCD. First, we need to make a GCD function also, right? And the most optimized way of using the GCD function is the Euclid optimized algorithm. I have explained this GCD multiple times in my GFG POTD series, but here again, let's go again because it's very simple. So for int a and b, it is just saying that if b is equals to 0, then it says that return a, or else call the GCD for b or a person b. Right, so how it is working, we will not trust it blindly. Let's take an example as I always take. So for g to 15, it call for the function the b is copied. The b is copying at the 8th place, so 10, and it will be 15% 10, right? So that gives us 5, right? Then again, it will call for the function b will be copy here, that is 5, and 10% 5, that is gives us 0. So now it hits the base case that if b is equals to 0, return a. So that goes here the understanding of our GCD here. And what's the time complexity for this GCD? Now you can see that the 15, let's say 15 is reducing. 15 is reduced to 10, then it is reduced to 5, right? So it is reducing in the modulo of this a, right? So if some number is getting multiplied by 2, or divided by 2, or any multiplication or division by any number, let's say a or b, then we say then the complexity is log n, right? Log n. And I can see that the largest number here is always getting reduced, right? Suppose if you have taken 10 comma 15, then what would have been the case? That 15 was copied here, and then it should be like 10% 15, right? And it would give 10. So again you can see that it is getting, if also that if a and b is greater than, also it is converting into a sense that the first parameter is getting increased, and and it is adjusting like that, right? So I can say that the maximum of the number is getting reduced, right? Or I can say the minimum of this number, the minimum among 15 and 10, the minimum was 10, right? And it was getting reduced to 0. So I can say that it would be not log of n, but log of minimum of b comma a, right? Okay, so we discussed the time, so it will be like a constant time complexity there. Okay, so let's get back to our main question again. So we just need to find the GCD of each and every sibling as soon as we are traversing from top to bottom, and at the same time we need to maintain what a max GCD. So I will use a global variable outside the recursion, that is max GCD, and at every level I'll be calculating aware using this GCD function and storing it in a current GCD. And as soon as this current GCD is greater than the max one, we'll update the max GCD as current one. And at the same time we need to store one more thing. What would be the condition? If the current GCD I found is greater than the previous max GCD I made to track the max one, so I will say that the max GCD is equals to current GCD. And also I need one more variable, let's say answer, that will actually store the root dot data, right? Because this is our actual answer. Whenever we have the sibling which is actually having the more GCD, so for that sibling we need to return the root dot data, right? So I can see that this would be my one if of our pseudocode. And there will be some point where the current GCD and the max GCD we maintain will be equal, as we can see here. We started from top from 4 and we are coming to bottom, right? It will be like it calculated for 4 and the GCD is 1 and the max GCD was pointing to 0 at this time, so it would be updated. But when it calculated for the another sibling, that is 3 comma 1, so it says that is equal, right? And for that case, if it is equal, for that case we need to take the answer as the maximum of the root, the parent, maximum of the parent of those siblings, right? So what I can write here is that if, or else if current GCD is equals to max GCD, right? Then what I will say that I'm just writing this pseudocode here. It will, because I always say that whenever you are doing the recursion and thinking, always write the pseudocode at the same time, because it would be very difficult to think once and then write again, especially in case of recursion. So what I can write here is now the answer which I made variable that will be pointing to math.max, the previous answer, right? And the current root dot data, right? We are always storing the root dot data for any uh, current GCD which was greater than the maximum we maintained, right? Okay, so let's discuss the flow now, and then we will recurve for left and then we'll recurve for right. So let's discuss the flow now. Let me remove this GCD thing here. So how the things are happening is, let's discuss the recursion tree which I will draw for you. So I was at this point 4. I was at this point 4. I will see that if the left and right child is not null, then I will calculate it GCD. I will calculate the GCD of 5 comma 2 and will give as 1, right? And I will maintain a max GCD that will be updated to 1 now, and answer will be updated to its parent, so that is 4, right? And then I'll move left. So let's move left. So from 4 I'll come to 5. So now I'm at 5, and I will see that the both the childrens of 5, the both childrens, that is siblings, are null, right? So if that's the case, we do not have to do anything, right? We just have to return. We just have to return, right? So I can see the base case is, if root is equals to null, then I need to say return, right? So I will return from here. I will return from here, and I will then go to this thing, right? So I will calculate for 2 and I will pre-process it again. So I will found or I will find the GCD of 3 comma 1, that gives us as what? 1, right? So now my current GCD and the maximum GCD is pointing to the same, right? So what I will do, that I will update my answer as the maximum of the previous answer, that is the previous node where we got the GCD as 1, and the current node that which we are processing, that is 2. So the answer will be 4, right? So if the tree would have been just this much, we verified from the compiler that the answer will be 4, right? Okay. So from 2 we will again move left. So we go to 3. And 3, then we will again find that GCD of 6 and 12 is what? 6 is 6. So you can see that our current GCD is 6 and the maximum GCD is still 1. So you have to update your maximum GCD now. So I will say that my max GCD now pointing to 6, and the answer, since the GCD is getting update, then you have to update the answer as well, right? So answer will be updated to the root node for which the siblings was being processed as GCD. So the root node was 3, so it will update it to 3. Now where the pointer will go. So 2 to we went to left, then 3 to again we will go to left. So it will process 6 now, but 6 has the siblings as what? 6, it will go to 6 to left, and 6 left is null. So it will hit the base case that if root is equals to null, we just have to return. So it will return from 6 and then it will go to 12 root dot right, and it will just again hit the base case and it will again return, right? So the subtree of the two node, that is 3, 6 and 12, is complete. So it will now go to 1 and it will see that again the one left is null, and it will again hit the base case and it will return. So finally the all the tree traversal is done here. This will be the flow of the nodes that will be processed each after again. And the time complexity, as you can see, that we are visiting each node once, right? So it will be O of n, and it's a pre-order traversal. And since we are using recursive stack, the space complexity will be O of height of the tree, height of tree. Because at a particular time, the maximum number of recursive call you will store in the recursive stack is the height of the tree. So let's say you have a skewed tree right here, 4 3 2, and then you have 1. Then what you will do, you will process for 4, you will move left, you will process for 5, then you will move left. And these all are things that is in the recursive stack. So as soon as 3 hits the base case that the children is null, it will start processing the right, it will start freeing up the left nodes. So I hope you're getting the why the space complexity is a height of tree. And time complexity is also, we are doing some for each and every node. For each and every node, we are doing some work, that is n plus what log of minimum of a comma b, right? So let's see that the value of nodes, what's the data of node is 10 power 5, right? So let's see if it is not going out of bound of 10 power 8. So it is O of 10 power 5 into log of minimum of 10 power 5 minus 10 power 5. So it would be considered as constant only. So it would be not considered as a time complexity, right? So okay, so it will be like O of n, the time complexity, and the space complexity will be the height of tree. And since n is 10 power 5, it will be in less than 10 power 8. And if we will be able to code this approach, so it will be submitted. So let's do it. So let's decide the steps. What are the steps here? We'll have to make some GCD function, and after making the GCD function, we need some variables like max GCD, the answer, and we need to do pre-order traversal. So let's do it. So let's make the function for GCD, the Euclid optimized algorithm, that is GCD int a int b, and that is b is equals to 0, then return a, else return GCD of b comma a percent b, right? So this goes our GCD code, and we need some global variables. So let's make it, because for each and every sibling we need to calculate a current GCD, right? So we need to maintain the track of maximum GCD. Let's point it to, and GCD, the minimum GCD will be 1, right? So it cannot go beyond less than 1. And answer, and let's make an answer variable that will be actually storing the root node. Okay. Okay, so let's do the pre-order traversal now. So it will be void pre-order node root, right? So the first base case that we discussed was if root is equals to null, then we need to return. And if it is not null, then we need to check if both of its children exist or not. So I will just check it. If root dot right is not equals to null, and then root dot left is not equals to null, both children should exist, then what I will do, I will find the GCD. So I will use a variable in the current GCD, and I will use the function we just made, GCD, and I will pass the data, root dot left dot data comma root dot right dot data, right? And I will compare that if current GCD we just calculated for a sibling, if it is greater than the max GCD we made as the global variable in an answer, then we will update the max GCD, right? So max GCD is equals to current GCD, and we will update the answer, which is actually storing the root data, root dot data. So there was another case we discussed in the pseudocode, that there may be a case as mentioned in the question that the current GCD we calculated, like more than like multiple pairs, or let's say two pair, or let's say multiple pairs can have the same GCD, right? As we can see in this example. if the tree was just 4, 5, 2, and 3, 1, not the 6 and 12. So you could see that the GCD of 5 and 2 is 1, 3 and 1 is 1. So let's code that step. That with the current GCD is equals to the max GCD. Then what we have to do? Then we have to update our answer with the maximum value of the root data. So I will update the answer as answer, comma, the current root data which is having the GCD equals to as max GCD. So that is it. And we just need to recur in the left part. So that is root dot left and pre root dot right. So why choose left to right? Because it's a standard pre-order traversal. You can do right to left also. That doesn't matter. We just have to do the traversal. Okay. So I think we are good to go now. And in the main function, we need to call the functions we made, right? The pre-order traversal. We pass the parameter as root, and the answer will have all the computed things in there, and I will return answer. So let's compile and run. And we already discussed the time complexity, but let's compile and run as for now. And you can see here your output and expected output matches. Also, there was a base case here, right? So I need to mention that case also. So if root, since they are given in the node, so we need to take care of that, right? So return 0 if the input. So if root is equals to null, so I will say return -1. Okay, so we are good to go now. So let's hit the submit button. And we already discussed the time complexity. It will be O of n, as well as the space complexity, since it takes the height of the tree. So that's it for the today's video. Hope you like the video and my content. So please subscribe to our channel and let's keep growing together. Few last things: that this is my DSA repository. You can start and fork to get help with the source code, and that's my Instagram channel, specially made for my DSA with Akshay. So you can connect me here regarding any doubts or guidance if you want. And till then, take care, keep solving, keep studying, and keep growing. Bye bye.